Hi, folks. Thank you for coming. My name is Maxim Mazin, and I work at JetBrains since 2006. And until the last year, I was leading the YouTrack team. YouTrack is backend issue tracker by JetBrains, written almost all in Kotlin as well. But since this year, I'm a part of Space project. I'm software engineer there, and that's why I'm going to talk about Kotlin technologies we're using in Space and like how we use Kotlin to build this product. If you missed yesterday's announcement and still somehow end up here, Space is a new integrated team environment by JetBrains. It contains all parts your teams need to work and communicate and to deliver stuff. Are they developers or not? Doesn't matter. Still, everybody is welcome. And Space is full stack Kotlin. It means that we have different environments where Space is running. It is JVM on server side. It is IDE plugin. It is Android and iOS applications. And we have Kotlin.js framework, web front end that we use to build our web application, and we use it as well for our Electron application right now. We reuse a lot of code using Kotlin, and thanks to Kotlin multi-platform, it enables us to do it. But we are using a pragmatic approach to multi-platform. Normally, when you have, say, JVM backend and JavaScript front end, you share some data. Maybe you generate some data model classes for JavaScript. Maybe you generate some RPC methods, but that's it. With Kotlin, we also are able to reuse view models that are going to the server side, fetching data, layout it somehow in memory, and then make accessible for UI components to be drawn. We reuse common libraries, utilities, and data model sure as well. But we don't reuse UI components. We think that like every platform has its own infrastructure, and you want your application to look native on iOS, and you can hardly achieve it using frameworks that enable you to write one UI code and use it everywhere. So we don't reuse this. And storage available on different devices and in different client environments are also different, with specific requirements to the amount of data you can store and how you can store. So the storage part is also not reused, but pretty big part of code is actually reused. It enables us to create features quite fast. So say we want to reuse this data class. It's some data class for a holiday. It has name and it has date. And there is, in Kotlin standard library, there is string type, but unfortunately, there is still no local date. So we can do something with it. We can declare it using the Kotlin MPP. We can declare local date without any fields. And we can use actual keyword to define the particular implementation for the platform using type ls. So using this, normally for each platform you have some kind of implementation of such things as date times, so you can reuse the vast majority of functionality from there. Local date is not just a presentation of data, but also you need some, with it you need some operations, so we can use expect actual functions here to implement this. You can see that in different languages this looks pretty different, but your API, that is your libraries and your models that you are using in your application, they don't need to cope with it. They can just use these basic methods declared in common code. Next, I'm going to talk a little bit about frameworks that we are using to build Space. And first one will be Exposed. Exposed is an open source framework. You can use it. it provides you with some functions for type-safe SQL writing and for object relational mapping, like Hibernate for Java. You can use Exposed for Kotlin. In Exposed, you define tables like this. This is pretty similar to what you would have in SQL, defining table, but you have reference consistency if you do it this way. So after you declared the table, like in Kotlin, you can then reference its columns in your Kotlin code without any stringly typed stuff. To create database, you actually connect to it, and then you can use your schema defined in several tables. You like here in user table, you can actually upload this SQL, initialize this SQL schema. The cool thing about Exposed that it can track the changes in your model, and after each restart, it applies the migration, so it adds required columns and missing tables and so on. For sure, there are some cases that we cannot cover this way, so in that case, you need to write code manually, like migrating, adding some default values for that. To insert data in table, you use something pretty similar to your SQL statement, but referring columns in Kotlin. To query database, you use syntax like that. It's not only the way you can interact with database from Exposed, you can also define entities. You define a class. This is a part of the object relational mapping. You can define a class. You can link it to some table. You should define its companion object to be an e-factory that will provide you with a number of methods like create new entity, query all entities of that type, and so on. And then, thanks to property delegation in Kotlin, you can define different properties, mapping them to columns in a table. So after that, creation of new entities in a table becomes more object-oriented. So you just use this factory method, initialize fields, and that's it. Searching is pretty the same. So you can query, you can interact with tables like with just queries of entities. Next part of that drives our application is Ktor. It's open source as well. You can use it like we do. It is both server and client, so you can define your server side using Ktor. It's one-day cell, and also you can use multi-platform client, so you don't need to bother how exactly you need to communicate with HTTP from JavaScript or JVM or other places. So this part is multi-platform, and it helps us to write our clients. And Ktor is completely asynchronous. So when you define some endpoint on server side, you define it in a synchronous way. It's not blocking. When you call something from the client side, it is also asynchronous, so it's also not blocking. You define and run server right from code. You don't need to bother to create some servlet container, deploy there your WAR files or whatever. You just create a server, initialize it, and then you start it. That's it. Ktor supports a number of features for authentication, for routing, for different stuff. Yeah. But almost, I'm pretty sure that if you use Ktor, you will use routing because you need to define like how your application handles different endpoints. So you define routing like this. Then inside it, you define different methods, and then inside the method, you can this lambda that is passed to the get method is suspended function. So you can have your asynchronous code. You can go to database, in non-blocking manner, or you can read from somewhere else, or right. The cool thing that Ktor consists of different modules, so you can define part of routing like this here, you can define another part of routing this way in another place, and you can build your application from different parts, and it actually enables us to create plugins, where you can create plugin, and it provides some additional endpoints without any additional effort. Yeah. Ktor supports WebSockets. It looks like this. So you just assign some lambda to a URL, and there is a socket. The cool thing here about Kotlin is because of coroutines, you can have code like this, right? Code like this, where you need to define an endpoint, and you need to say what happens on open, on message, and so on. You can have it like this, where this on connect happens at the beginning on open. At the beginning of this section, then on message happens every time you read next frame from the incoming source. On close is an exception, and on error is also an exception. So you don't have this split it in several parts, pieces of codes that should interact and pass data to each other. You have linear flow of code. That's because of coroutines. We're unfortunately, or like fortunately, there is no still support for remote procedure call in Kotlin X serialization, but as far as I know, there is some plans. So we had to implement our own WebSocket RPC. You can define some class like that. Then we define interface, which has all its methods suspended, so it's asynchronous. We wrote some generator that generates proxy to be used on the client side, and you see that this proxy accepts API service. It's actually just a data class that contains information about the endpoint where the space server lives and some authentication. And thanks to extension functions in Kotlin, we can say that our users is an extension for API service. So after that, when we use it from the calling side, we can say like API.users, like this API contains all the data. It's just a simple trick, I guess everybody of us use every time. And once again, because of this is asynchronous suspend function, you can do things like that. You don't need to handle some on ready or other events. You can show loader, you can make your call, you can hide loader. Code becomes linear and simple as well. To make it all working, we need to implement this interface on the server side. So for instance, in Space we are doing like all the business logic more or less here in this place. So we check permissions, we open transaction, create a new user, and return it. I do know all the controversy about this implementation delegation. By the way, how many people are hating implementation delegation here? Oh, not too many, okay, that's fine. People on the internet are much more angry than in the audience. Yeah, but this feature helps us to put all these permissions and transaction methods into context and access them without having a prefix like context.permissions or context.transaction. This is just a nice way. It's shortened code a little bit. And now the cool thing. Having everything written in Kotlin, you can do things like following. You have some UI code where you have the call to create new user. You can navigate from there. You can navigate to the definition of this method. From there, you can navigate to implementation of this method, then to entity declaration, and then to database. So you can you can navigate and you have reference consistency for your entire application. So you can get from where you are, you can get to any part of the application, and there is no barrier. So if you are a front-end developer, you still can go and check like what is the limit for the number of characters in this column. It's not like you need to know where the handler for that method on the server or something like that. And vice versa, if you say you see some table that you think is not used anymore, you can search for usages and you can find all usages back to the very front end to understand like, is it actually used or is it some piece of dead code? So reference consistency is a cool thing that you get when you're using Kotlin full stack. We are not only use these interfaces ourselves, but we also use them to define HTTP API. We are pretty sure that it is important to use the same methods or to give the same methods that we use ourselves to create front end, to give them to end users, because otherwise, if you don't do it, if we have HTTP API somewhere separately, we will end up in the situation where we are adding some functionality that is in some gray area that is not usable by our customers, and it's not cool. So technically we can have some functionality that is in gray area if we like do not mark some of these methods with the annotation, but we do. From that declaration we can generate playground. So you can get into space, you can get there to the administrator HTTP API playground, and you can trigger different methods right from the UI. It's quite handy. For sure, we generate Kotlin client. It's not in the Maven repository yet, I mean public Maven repository yet, but it will happen soon. We support partial requests here, you know, like GraphQL and all these things. And if for some reason you decided not to use Kotlin, we generate our Swagger OpenAPI JSON, also known as Swagger. So you can take it, stick into code generator, and get code generated library from Swagger code generated library. Next, I'm going to talk a little bit about our front-end technologies. First of all, it's Kotlin React. Kotlin React is open source, available at GitHub. Actually, it's available on GitHub as a part of the Kotlin wrappers. It's a repository with different JavaScript, Kotlin JavaScript wrappers. So it is Kotlin DSL for React, and it looks like that. So in some, it gives because it's Kotlin, it provides you with some additional features you don't have if you use it in JavaScript. For instance, you define properties like an interface, and it is strictly typed. And if you are using React.js, you can have some type checking, but this type checking happens on runtime, and you need to bother passing property types that are a little bit decoupled from main code. So having it strictly typed is nice. You inherit from R component, and then you write the body of your component in Kotlin XHTML. Kotlin XHTML is a Kotlin common library, so you can use it on different platforms, and we'll get back to it a bit later. When you want to use some component, you need to embed it, you need to put it to your markup, and you do it like this. This doesn't look nice, so you can define nicer method, and what actually happens when you define components, you can create methods like that, and after that you can use this XUser component right the way you would use any other markup methods, which is pretty handy. Next thing is style component. There is a Kotlin wrapper for style component. It's Kotlin DSL, but for CSS now. It provides you with the type safe CSS declarations. So the cool thing, you define your component, and you put your CSS code right into this component, and not like somewhere else. So you can maintain your code together, together with logic and together with markup. You can also define your style somewhere else. In that case, In that case, this generated code will have some nicer name. Like if you generate this style here, you can reference it. You can reference it like that, and it will embed CSS. The good thing that if you have this CSS inlined, it won't generate you actually inline CSS, like garbaging your entire generated HTML, but it rather creates a dynamic CSS class and then reference it. Because of that, you can do different mixtures like that. So you can reference user styles plugin. It will be inserted as a class. And you can also, as it's Kotlin logic, you can also put this logic right here. You can check if user is admin, for instance. And then, in that case, you can add class for its color. We have email notifications, and email notifications is something specific. Normally, you write email notifications some framework like FreeMarker, but we do it right in Kotlin, and we are using Kotlin X HTML once again, and we are using the same markup, the markup that looks the same as our front-end markup, but with some additional features. When we generate it, as you might know, you cannot use classes, and you are really limited in CSS attributes when you are rendering emails. So we can handle it, and we can embed these classes and styles. We can embed right into generated tag elements of the email. And the syntax is the same. Tests for sure we are writing in Kotlin as well. We are using JUnit for like API tests. We use this trick. How many of you are using this trick for tests? Very nice, cool. We use this trick to have nicer names for tests. For other places, it doesn't work that well. And we are using assert K to have nicer assertions. It enables you to, if something fails, it doesn't give you something like John Doe is not equal to Jane Doe. It explains you a little bit what was going on there. Our web client tests we are writing also in Kotlin. We don't have too many of them. We are using them to use to test our components. We are using Enzyme underneath. And we have this sort of Kotlin wrapper around it to check stuff when we're dealing with components. And the last thing important here, I guess, is the WebDriver tests. WebDriver tests are also in Kotlin and also using JUnit for definition of the pages and the content of the page we are testing. We are using HTML elements. It's a library by Yandex. Quite nice. It enables you to define the structure of your page, some behavior on that page, and then your Selenium or WebDriver test doesn't look like a complete mess. It looks like you are going here and there and clicking stuff, and not like you are creating some drivers, wrappers, and so on. For reports for the WebDriver test, we're using Allure. It allows you to split your test into several steps. And after you have the test run, you get this nice report. You can have screenshot there. You can have different stages. So for UI tests, it's really handy to find out what went wrong. And when the test fails, it also attaches screenshots, so we can see how did it look and why your code didn't find some button there or something like that. We are not using Kotlin ourselves. We force our users to use it as well. We are using Kotlin as a language for automation scripts. So this is how code for running a Gradle build may look like. So you define a job. It's a unit of work for our automation. You say that you want to run this job in a Gradle container. in a Gradle Docker container, and then you define the script. Like this is Lambda that is actually, this is imperative code you can use, and you can define what you want, how you want to run it. So you can have some logic here, like checking if the current branch you are building is release. You can add some parameters for the Gradle script, and it will change the behavior. This, like all these technologies, they are all in Kotlin. And because we are using Kotlin everywhere, we can have full stack Kotlin developers. But people cannot be that sure, like when they are creating some style CSS and code and front end, and at the same time be experts in iOS development and tweaking S3 or something like that. That's why we're having this separation in team. Like there are people who are working more on the platform-related things, like on backend platform or front-end platform or iOS platform, and there are people who are using these platforms to create features. This combination of specialities enables us to deliver features pretty fast. So here are the libraries I was talking about and mentioned during my talk. Thank you, and remember to vote.